section 6.3, it's also style problems called max and min problems. Now we've looked at some of these already in the other examples. The solve max and min problem, you have to determine the highest or lowest point. So that's the vertex, as you know. And determine the maximum minimum value. We'll use this equation, negative b divided by 2a, and we'll substitute that answer, which is the axis symmetry, into our equation. That will let us either find the maximum value or the minimum value. So you have to keep in mind if the graph is pointing up, there will always be a minimum value. And if the graph is pointing down, there will always be a maximum. So, first example, a rectangular play area enclosed for some dogs has to be made with 60 meters of fencing, using the kennel as one side of the enclosure shown. So you only have 60 meters of fencing. And so to save on fencing, and get the biggest area possible, you'll use one side of the kennel as a fence. So only these three sides are actually made at the 60 meters. So it's only 60 meters. The quadratic function that models the area of the enclosure is represented by the function as shown here, where ax represents the total area enclosed and x is the width. So this is a function, the area depends on the width. So you put the width in here, it will come back and calculate the area for you. So determine the maximum area. Well, when we look at this graph first, or the equation, we know that the graph is going to point down, which means there has to be a maximum. Now look, doing a little sketch of these before we get too far into them. Now I don't know exactly how the graph is going to look, but I do know it should have this shape. So the x values we were told is the width, and these values here are the area. So when do we get the maximum area? You know it's at the vertex. And what width gives us that? Well, that's our axis of symmetry. So we use our negative b divided by 2a. So x equals negative, and b is 60. 2 times a is negative 2, negative 60 over negative 4, which is 15. So when the width is 15 meters, that's when you have the maximum area. Now we need to find the area. So you have 15 meters on this side, 15 there. So that's 30 meters used, and you only have 60. So you only have 60, take away the 30 that use up the width, which means you get 30 used here for length. So that's from here over there. So the area is 15 times 30. Or 450 meters square. Now the next one is a similar style problem, and it says we have a rectangular region placed against the wall of a house. It's divided into 3 regions of equal area using a total of 120 meters. Fencing is shown, and here's the quadratic formula. And x represents the area of the enclosure. Ax represents the area of the enclosure, and x represents the width. So you only have 120 meters. So if you have 3 regions or 3 sections, here, here, and there, this is length of x, and since it's a rectangle, all of them have the same width down through. Use wall of the house as one section. So now this length right here, you had 120 meters available, but 4 of these lengths are taken up in the dividers, So this here, so length is 120 meters of total fencing. Subtract what you're using for each of these dividers. So the dividers are here. And there. So that's the 4x. So maximum area. So if you think of the graph for this situation, the A value is negative, so the graph points down. So the graph will go up, down. The maximum area will be here. And when it occurs is the axis of symmetry. That's given by negative b over 2a. So negative 120. That's from here over 2 times negative 4. So negative 120 divided by negative 8. Oops, no, that's wrong. So that will be 15. So here, 15 meters. So we're using 15 here, 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 and there. That length in here is 120. Subtract 4 of the 15s that are used to make the dividers. Subtract 60. So our length, 60 meters. So then the area, 15 times 60. And that will be 900 meters squared. So when the width is 15, the area works out to be 900 meters squared. Now the domain and range of the variables in the function. The first range would be the easiest to figure out. So the y values are less than or equal to 900, and y belongs to the reals or the real numbers, and the domain domain is going to be from here to there. Now we don't need to do anything to figure that out except realize that if this is the axis of symmetry, it's 15. So if it's 15 to the middle, there must be 30 to the end. So x is less than or equal to 30, greater than or equal to 0, and the x values belong to the real numbers.